Okay, so this lesson we're going to be looking at parallelograms. So what are parallelograms? Here are the characteristics we're going to be looking at. A quadrilateral with the following characteristics. Opposite sides are parallel and congruent. So in a parallelogram, the opposite sides will be parallel and congruent. That's what makes them a parallelogram. Other characteristics that occur are opposite angles are congruent. So A and C would be congruent, B and D would be congruent. Consecutive angles are supplementary. These are supplementary, these are supplementary, those are supplementary, and those. Okay? Mainly because these are all parallel lines, and so we have transversals and parallel lines. So all those congruent angle theorems apply. So these would be consecutive interior, these would be consecutive interior, and so forth and so on. The diagonals bisect each other. So even though I didn't put the marks in here, the diagonals will bisect each other. So these two segments are congruent, and these two segments will be congruent. Okay, so if you have a parallelogram, you know these things are happening. And then we can use that to do whatever questions that we have, proofs and such like that. But we're going to be looking at examples and how to solve some problems. So we're going to look at an example right here, how I can use these characteristics to help me solve some problems. So here we have example number 1. We have a quadrilateral PQRS. PQRS is a parallelogram. What is the value of X? So what I know, because this is a parallelogram, because you told me such, opposite sides will be parallel and congruent. This means, for part A, I simply need to take a pair of opposite sides and set them equal to each other in length. In doing that, I can then move the 5 over here, which gives me a negative x equals negative 3, so x equals 3. And then you can double check it with the other side. If I take a 3 and plug it in here, that would be 21 minus 3 is 18. Plug it in a 3 in here, be 2 times 3 is 6. 6 plus 12 is 18. So we have confirmed that to be true. And then the last one here is what is the length of each side? Okay, so then clearly what they want you to do then is go ahead and plug things in. So what is QP? Well, that is 4 times 3, which is 12. What is RS? 5 times 3 minus 3, 15 minus 3, 12. What is QR? 7 times 3 minus 3, which we already did, was 18. And we already did the last one here, but here it is on paper. And 2 times 3 plus 12 is 18. So what you should see when you get done doing this is that opposite sides are indeed the same length. Okay. We also have problems, characteristics for angles, and that's what this one is illustrating. So here is a parallelogram. What is the value of A? Well, in a parallelogram, consecutive angles are supplementary. So that is your key there. So that means this angle plus this angle is 180. So then add them up. So A plus 5, and then 8A minus 5 must equal 180. And so then I can solve this for A. I have 9 A's. 5 and minus 5 is 0. And so then A must be equal to 20. And then I can use that value to find the measurement of these angles in part B. So what is the measure of angle G? Well, it is 8 times 20 minus 5, which gives me 155 degrees. What is the measure of angle H? Well, it is 20 plus 5, which is 25. Okay, and another parallelogram question right here. Given a parallelogram with this information, what are these values? Well, to do that, we should try and draw a picture of a parallelogram. It doesn't matter what it looks like. So just draw any generic parallelogram. and assume that it is correct. So we have an R S T U. Okay. S K. Well, there is no K. How do I find S K? Well, S U is 35. So this distance, this diagonal is 35. Here's a KT. So where is KT? Well, where's the K? Usually in a situation like that, because there's none drawn, and you have one diagonal drawn, you draw the other diagonal, and the point where they intersect is K. So that's how that works. So I know the whole diagonal here is 35. I know this is 19. And what do we know about the diagonals of a parallelogram? We know that they bisect each other. So even though I'm going a little bit out of order, if that's 19, I know that's 19. I know that if this is 35, then this distance from here to here is half of that. So whatever 35 divided by 2 is. And this is 35 divided by 2 because the diagonals bisect each other. So with that information, I can come over here and figure out these answers. So SK is 1/2 of whatever SU is, which means that is 35 over 2 because the diagonals bisect each other. Bisected diagonals is Y. So what is RT? RT is 2 times KT, or 2 times the 19 they gave us, which is 38. So that's how I can do diagonals. Okay. So let's look at some more that we can do with this. So here's another example. I can give in this parallelogram. I'm telling you that PK is 4, so I know that this is a 4. I know the whole distance is that, but I also know that from here to here is also 4 because the diagonals bisect each other. So then I can go and take this thing. I want to find what GP is. I want to find this distance right here. Okay. But in here, I can work this out. So here is a formula that I can use. So HK is 2 of these PKs, which is 2 times 4, which is 8, which is what we already established, that it was 8. Okay. From this formula right here, I know that HK is 2/3 of whatever GJ is. So then I can plug in my numbers and solve for this. So this is an 8, 2/3 GJ. I can solve for this by multiplying both sides by 3 over 2. So if I multiply this side by 3 over 2 and this side by 3 over 2, these will drop out because they're reciprocals of each other to become a 1. This over here becomes 12, and I got GJ is equal to 12. And since I'm trying to find GP, I know that GP is 1/2 of whatever that GJ was, which is 1/2 of 12, which is 6. And there's how you can do that one. And then here is another diagonal one using algebraic expressions. Here's a parallelogram. Find P and Q. And there's little expressions on each one of these little pieces here. And so then what do I know? Since the diagonals bisect each other, I can just take these things and set them equal to each other. So 7P plus 1 must be 5P plus 3. And then I can solve that for P. For the Q's, I know that 3Q plus 1 is 2Q plus 3. And I can solve this for Q. Subtract the 2Q, subtract the 1, and I get Q equals 2. And over here, I get 2P equals 2, so P equals 1. And that's how I can do some of these problems. Okay, so that ends this lesson on parallelograms, and we will do more problems together in class.